What is green tech? Green tech refers to a type of technology that is considered environmentally friendly based on its production process or its supply chain. Green technology, abbreviation of green technology, can also refer to clean energy production, the use of alternative fuels, and technologies that are less harmful to the environment than fossil fuels. History of green technology. While green tech has become increasingly popular in the modern age, elements of these business practices have been in use since the Industrial Revolution. Beginning in the early 19th century, scientists began to observe the ecological impacts of coal burning industrial plants, and manufacturers have sought to reduce their negative environmental externalities by altering production process to produce less soot or waste byproducts. In the United States, one of the most important milestones was the Second World War. In order to reduce consumption and waste, more than 400,000 volunteers began collecting metal, paper, rubber, and other materials for the war effort. Following the war, scientists like Rachel Carson began warning of the consequences of chemical pesticides, while doctors abroad reported mysterious illnesses associated with nuclear radiation. Many point to this era as the genesis of the ecological movement, which sought to preserve ecosystems and resources while raising awareness of the consequences of runaway technology. Government bodies slowly recognized the importance of protecting environmental resources. Curbside recycling programs became common over the following decades, raising awareness about household waste. The Environmental Protection Agency, established in 1970, set firm requirements on pollution and waste and established mandates for coal scrubbers and other clean technologies. The future of green technology holds promise for innovative solutions that can address pressing environmental challenges and promote sustainability across various sectors. Here are several key trends and developments that may shape the future of green technology. Advancements in renewable energy. Continued research and development in renewable energy sources such as solar, wind, hydroelectric, and geothermal power are expected to drive down costs, improve efficiency, and enhance reliability. Energy storage solutions. Breakthroughs in energy storage technologies, including battery storage, hydrogen storage, and thermal storage, will play a crucial role in enabling the widespread adoption of renewable energy and reducing reliance on fossil fuels. This will facilitate the transition to a more decentralized and resilient energy infrastructure. Electrification of transportation. The electrification of transportation, including electric vehicles, EVs, buses, and trucks, will continue to accelerate, supported by advancements in battery technology, charging infrastructure, and policy incentives. This shift away from internal combustion engines will reduce greenhouse gas emissions and air pollution in urban areas. Decarbonization of industry. Industries such as manufacturing, agriculture, and heavy transportation are exploring strategies to decarbonize their operations through the adoption of cleaner technologies, process optimization, and the use of renewable energy sources. Carbon capture and utilization technologies will also play a role in mitigating emissions from industrial processes. Circular economy initiatives. The transition to a circular economy model, where products and materials are designed for reuse, recycling, and resource recovery, will gain momentum. Innovations in materials science, product design, and waste management will enable the development of closed loop systems that minimize waste and maximize resource efficiency. Smart cities and sustainable urban development. The concept of smart cities, characterized by integrated digital technologies and sustainable infrastructure, will continue to evolve. Smart city solutions, including energy efficient buildings, intelligent transportation systems, and urban analytics, will enhance resource management, reduce emissions, and improve quality of life for residents. Nature based solutions such as green infrastructure, ecosystem restoration, and sustainable land management practices will play a vital role in climate adaptation and resilience building efforts. These approaches leverage natural processes to mitigate the impacts of climate change, enhance biodiversity, and protect ecosystems. Collaborative innovation and partnerships collaboration among governments, businesses, research institutions, and civil society organizations will be essential to drive innovation, scale up clean technologies, and overcome barriers to implementation. Public-private partnerships, technology transfer initiatives, and knowledge sharing networks will facilitate the exchange of ideas and best practices. Policy and regulatory support strong policy frameworks, including carbon pricing mechanisms, renewable energy mandates, and environmental regulations, will provide incentives for investment in green technologies and drive market transformation. Governments at the national and international levels will need to collaborate to set ambitious targets and create an enabling environment for sustainable development. Public awareness and education, increasing public awareness of environmental issues and the importance of sustainability will drive demand for green products and services. Education and outreach efforts will empower individuals and communities to adopt more sustainable lifestyles, support eco-friendly businesses, and advocate for policy changes that prioritize environmental protection and climate action. Overall, the future of green technology holds significant potential to address global environmental challenges, promote economic growth, and improve the well-being of present and future generations. By embracing innovation, collaboration, and sustainable practices, societies can transition towards a more resilient and equitable future. Although market for green technology is relatively young, it has garnered a significant amount of investor interest due to increasing awareness about the impacts of climate change and the depletion of natural resources. Key takeaways: green tech or green technology is an umbrella term that describes the use of technology and science to reduce human impacts on the natural environment. Green technology encompasses a wide area of scientific research, including energy, atmospheric science, agriculture, material science, and hydrology. Many green technologies aim to reduce emissions of carbon dioxide and other greenhouse gases in order to prevent climate change. Solar power is one of the most successful green technologies and is now cheaper to deploy than fossil fuels in many countries. Investors can support green technology by buying stocks, mutual funds, or bonds that support environmentally friendly technology. Adoption of green tech. While green tech is a broad and hard to define category, some types of green technology have experienced wide adoption. Several countries have launched initiatives to eliminate single-use plastics, a goal that would require sizable investments in alternatives such as paper substitutes, bioplastics, or recycling technologies. Singapore, for example, has pledged to reach 70% recycling by 2030. Renewable energy is another frontier for green tech adoption, with fossil fuels recognized as a significant driver for climate change. According to the Energy Information Administration, solar and wind power together accounted for 70% of the new energy capacity added in 2021. In 2021, worldwide, global investment in all renewable energy sources exceeded $300 billion in 2020. Special considerations: while green technologies have the shared goal of preserving biodiversity and conserving the Earth's resources, there are few ways to do so without affecting the environment in other ways. In some cases, reducing environmental costs in one area means causing adverse impacts in another. For example, the batteries in electric vehicles rely on lithium, an element that is often strip mined from South American rainforests. Hydroelectric dams have low carbon emissions, but high impacts on the salmon and other species that rely on those waterways. Green energy devices such as solar panels and wind turbines require a host of rare minerals that can only be extracted by diesel-powered mining machinery. This does not necessarily mean that green technology is a lost cause, but it does require careful accounting to ensure that the benefits outweigh the costs. What is the cheapest form of green energy? The cheapest form of alternative energy is solar power, according to the International Energy Agency. In its 2020 World Outlook report, the agency found that photovoltaic solar energy is consistently cheaper than new coal or gas-fired power plants in most countries, and solar projects now offer some of the lowest cost electricity ever seen. Is nuclear power green? Nuclear power is a deeply controversial subject, and many scientists have disputed its benefits. Although nuclear power derived from fission can provide reliable, inexpensive electricity without greenhouse gases, it also produces highly radioactive waste that must be stored for thousands of years. Some activists have argued that nuclear power can never be safely generated, and a number of high profile accidents, notably at Chernobyl and Fukushima, have highlighted these concerns. However, it should also be noted that the combined death toll from nuclear accidents is far lower than the annual fatalities from fossil fuel pollution. Thank you.